Alright, so we know that the integral of a to the power x dx is actually a to the power x divided by the natural log of a, right? For example, the integral of 2 to power x dx is 2 to power x divided by natural log of a, right? So what about the integral of 2 to power root of 3x plus 1? How do we go about that? Okay, so let's try to do that in this video. So I'll try to delete this. I'll leave this fact here because we may want to use it at one time. So the technique I'm going to use for this is to change the variable. I'm going to let u to be equal to 3x plus 1 because somehow the derivative of that 3x plus 1 under a root is going to involve 3x plus 1 again. So let's try to do that. Now I'll let u to be equal to the square root of 3x plus 1. So of course this is the same as 3x plus 1 to the power a half, right? So if I take derivatives on both sides, du dx is, so let's see what's this. This is going to be a half, right? A half. This is 3x plus 1 to the power negative a half times 3, right? So this is 3 divided by 2, the square root of 3x plus 1. Okay, hope you can see that. So just try to create more space here. Alright, so du dx is actually 3 divided by 2. You see, the square root of 3x plus 1 is the u that we let initially. So there we go. So of course dx from this expression, dx is going to be 2u divided by 3 times du. So where there is dx, I'm going to substitute this. So let's go ahead and plug that in here. So we have the integral of, so I write 2 to the power u times this 2 over 3, right? Okay, 2 over 3u times du. I think I should get another color here. So that's the, so I pull out 2/3 because that's, okay, constant. So 2/3 divided by, sorry, times the integral of u times 2 to the power u du. Alright, so we have another problem again. So how do we go about this? We have u times 2 to power u. We cannot simplify this as one thing using indices. So the only thing we can do now is to integrate by parts. Okay, so I'm going to use the table method of integrating by parts. It just turns out to be really much easier in this case, especially since we have u which can be differentiated up to 0. So my table is not good. So I'm going to write the function that we can differentiate in this column, and then the function that we can integrate, I'll write it in this column. Here I'll have plus, minus, and so on. So the function that we can actually differentiate to 0 is u. If we differentiate that the first time, we'll get 1. The next time we'll get 0. So that's enough. The function that we can integrate here is 2 to power u. The integral of 2 to power u from this fact here, this is 2 to power u. Okay, am I right? 2 to power u divided by natural log of u. If we integrate this one more time, that's 2 to power u divided by natural log of u squared. Alright, so there we go. So okay, let's do this. So we have this times this and this times this. So I can now write the final answer here just for this integral. This is 2/3 of, so the integral of this is u times 2u, sorry, u times 2 to the power u divided by natural log of u. Okay, next is minus 2 to the power u divided by natural log of u squared. I guess I can write that as natural log squared of u. Okay. Finally, I substitute back u for root 3x plus 1. So my final answer is 2/3 of, where there is u, I write there root of 3x plus 1 times 2 to the power root of 3x plus 1, okay, divided by the natural log of the root of 3x plus 1 minus 2 to the power the square root of 3x plus 1 divided by ln squared of the square root of 3x plus 1. Alright, so you can go ahead and actually factorize out the 2 to power 3x plus 1, 2 to power 3x plus 1. You can factorize that out here, and you combine it with these two, you know, it all works. So I don't have any more space, so I'll stop here. Thanks for watching this video. Please, if you have not subscribed, subscribe to the channel. I upload regular content about interesting problems in math and physics. Also comment below to tell me what you think, and I'll see you in my next video. Bye.